This is Mr. Beck Does Your Homework, AP Physics, Homework 8.1, questions 3 and 4. The window has a glass surface of 2908 centimeters squared. So I've got 2908 centimeters squared is my area. And a thickness of 8.5 millimeters. So 8.5 millimeters equals my thickness, which I use for L. Find the rate of energy transfer, that's H, by conduction through this pane when the temperature of the inside surface is 82 and the outside temperature is 99. So I'm going to get a delta T is going to be 99 minus 82 is going to be my delta T. Oh wait, but that's in Fahrenheit. That's going to be in Fahrenheit. So I'm going to have to do something with that. Assume the thermal conductivity of window glass is 0.8 joules per second meter degrees Celsius. So my K is going to be 0.8. So there are a couple tricks I have here. This is in centimeters, this is in millimeters, this is in Fahrenheit. The K is fine. Answer in units of kilowatts, so I've got to do a change in the end. So the first thing I need to do is my Fahrenheit. Well, Fahrenheit degrees are 5/9 the size of Celsius degrees. Celsius degrees are bigger. So if I take my delta T in Fahrenheit and I take that and I do times 5 divided by 9, that's going to give me my delta T in Celsius. So if I have a delta T in Fahrenheit and I do times 5 divided by 9, it'll give me my delta T in Celsius. You might say, well, what about the minus 32? Well, if I have this minus 32 and this minus 32, then the minus 32 gets canceled out in that operation. So really, you can just take 5/9 of your Fahrenheit delta. If you take 5/9 of your delta T in Fahrenheit, it'll give you your delta T in Celsius. So that's a trick with that. Your area is in centimeters squared, so you can't just divide this by 100 with 2 decimals. You have to divide it by 100 and then 100 again, because there's not 100 centimeters squared in a meter squared, but there's 100 times 100 centimeters squared in meters squared, so that's 4 decimal places. So for me, that's going to be 0.2908. The length is in millimeters, so if it's 8.5 millimeters, well, that's going to be 3 decimal places, so that's 0.0085 meters, and this is meters squared. So now I'm getting in units that I can work. So I've got meters squared, I've got meters. I'll take this times 5 divided by 9. That'll give me my delta T in Celsius, and my K is 0.8. So now finally I can do that my rate of heat transfer is Ka delta T over L, and I've put everything in proper units, so I'm going to get my rate of heat transfer. Now it says in kilowatts. Well, that's going to give me watts. So now I want kilowatts. So if this is so many thousand watts, I have to divide by 1,000 to know how many thousand watts I have. So I know that watts divided by 1,000 is going to give me kilowatts. So take that divided by 1,000. So that's going to be your answer here. For question 4, it says find the rate of energy transfer for the same inside temperature but an outside temperature of 0 degrees Fahrenheit. So my inside was 82 and my outside is going to be 0. So for the next one, I've got my delta T in Fahrenheit is going to be 82 minus 0. And if I take that and I do that times 5 divided by 9, that will equal my delta T in degrees Celsius. And then you're going to plug that in. Everything else is the same. So your K, your A, and your L are the same, but you'll have a different delta T. The key there is transferring the Fahrenheits to the Celsiuses.